This conference will now be recorded.
Right. To introduce myself Ravinder. I'm working as a SQL DB last 14 years. I'm working as Azure SQL DB close to 7 years now, and I do work on MongoDB and Postgres as well along with it, and I do work on AWS Cloud also on the SQL part. So let's get into this today's agenda. Today's agenda, we will talk about what is the importance of cloud, why we need to learn, and what are the factors actually attracting people to adopt to the cloud. What are the benefits the cloud technologies are giving? Why we need to learn? What is the importance? This is what we are going to cover today. The cloud benefits is a major focus today. What are the benefits people are getting by adopting the cloud and all? So you get a fair idea why we are learning cloud and why the cloud profile became mandatory for everyone. You will get a fair idea basically. So first I wanted to focus on on-prem data centers, how challenging for the people to maintain on-prem data centers, and to avoid that challenges they are trying to adapt to the cloud. So you will understand point by point as I'm going to take you through. So first we'll cover on-prem data centers and what was there before the cloud. The cloud is nowadays is started, but what was there before the cloud, right? That also very important to know. We will discuss about it. And virtualization. So nowadays, like anything that is saving the cost, people are very quickly adapting to it, right? So how the virtualization actually change the people's IT computing investment, we're going to take a little few seconds there and then move on to the next. Let's talk about on-prem data centers and how tough to maintain all of that. We'll see. First thing is to maintain their everyone's on your like own data centers. First, they need to find dedicated space for keeping the infrastructure. So that space must be safe against the natural calamities, and it must be safe against any unforeseen situations. Kind of they will investigate the place where they're going to deploy before they start building their data center. It's usual for anyone basically, because if it is prone to earthquakes, it is prone to natural calamities like floods, then it will be dangerous. Data is very important for any company, so they had to investigate that place it is safe against the natural calamities or not. So artificial calamities, no one can do anything like fire burn kind of thing. That is a different story. But anyway, they'll investigate the place where they deploy the data center. Next is high bandwidth internet provider. You never sit into the data center and work. You are operation center somewhere and you operate from somewhere. Everywhere it is happen like that only. So when you are pulling the data from your data center to serve your operation center, you need to have a proper bandwidth availability all the time so that your operation center never go down. Your productivity will not go down at all. So this must be maintained. And software licensing. Any company to run the different types of software. Some are maybe open source, some maybe definitely licensing. They'll have to keep track of how many licensing they are using it. They have to pay timely so that they don't get the penalties and they don't get the like unnecessary licensing issues kind of, right? They have to maintain it. Extremely redundant power. So you cannot expect that government will give you the power all the time because of local strikes, maybe floods, nearby area affected. So due to some reason, unforeseen situations, you may not get the power, but you cannot go to the client saying that I don't have power in my data center, I cannot serve you the data kind of. There is no way such you can claim that. You need to have an efficient UPS system immediately ready, or else you need to have a diesel generators, even the UPS systems get drained out. So you have to prepare yourself with all the standbys, right? That must be done by the person who is trying to build a data center. Dust free controlled environment within the data centers. It must be dust free controlled environment. If not, because servers run 24 by 7 365 days, the if the dust around the CPU fan accumulate the dust, and when you try to reboot, it won't reboot basically. Okay, so someone has to enter and clean that dust and then start the server kind of. It happens basically. Efficient cooling and air ventilation system. If you don't maintain the cooling, see the servers racks, this is how it looks like. They each one will generate a lot of heat. So if you don't keep the proper cooling system inside the data center, If the temperature goes beyond certain level, the circuits will break, which means that it is crash kind of thing. So that should not happen. You have to maintain your cooling system properly, especially in data center 16 to 24 degrees, that they do maintain the temperature to keep things, keep running, because they do generate. Even when you run your laptop for 2 3 hours, you see the heat that fan generates, right? So if you're running these many servers altogether, then they definitely generate the heat, so that must be maintained. Physical security. So if something happened to some of the server, someone has to repair the server, they had to be absolutely, like a authorized person, and some physical security will verify is really authorized or not. Then they'll let the people to enter, because your data is absolutely, you have to keep it safe. So definitely you have to keep the physical security who will verify the authorization of the people who are entering into the data center. And one more thing, you cannot rely on a single data center. You definitely have to build your DR data center as well. It is mandatory. Anything can happen to your data center. If you lose your data, you lost everything. Without data, you cannot operate at all. So you must create one standby data center also. You have to do all of this again in the standby data center also. This makes very expensive for any individual to maintain. So you buy a, like hardware, the latest hardware today. After 5 years, after 10 years, your hardware will become legacy, because the amount of data that is getting generated by the market is enormous nowadays. So when data becomes bigger, your legacy hardware won't scale. You have to replace with the new hardware which is latest in the market to serve with the current data requirement. So down the line, again, you have to replace your entire infrastructure. If it is a cloud, I'm just telling you one of the example. Cloud definitely give the immediate benefit if they use it properly. There should be proper cost optimization techniques people need to follow. If not, cloud is not cheap. Anyway, I'm going to tell you that the tips and tricks what we are using in our environment to maintain the cost. If you don't maintain the cost, though we are building a lot of databases, still we are trying to keep the infrastructure at the same cost. So how we are doing it? What are the tips we are following, tricks we got from the Microsoft anyway? Like we our client explain, like went to the Microsoft that this is too expensive, we cannot maintain kind of. There are some things they had told us, then we are following it. I'm going to share all of that what we are following in our environment anyway. But anyway, what I intention here is to maintain all of this. By when individual company or someone who are wanted to build their own data center, definitely expensive. On top of that, this is all about physical infrastructure what we are talking about. You need to have a different technicians to maintain all of this again, because you maintain different softwares, different hardware, right? So you have to have efficient employees to maintain all of that up and running. On top of that, if it is a cloud, things are different. How they are different, I'm going to talk in for the slide anyway, right? This is definitely an headache to maintain anyone on their own. There are many benefits along with it. I'm going to touch base today itself. Right, what was there before cloud? Cloud is a new technology, like it is there. AWS started in 2008 actually. So this is the oldest cloud technology is AWS actually. AWS is actually slowing, going behind the Azure. I'm going to tell you the reasons why it is so. But anyway, here data center, you see, managed data center is something like it's a cloud only. Before the cloud was evolved, are there, clouds are nowadays are globalized. Like if you take about AWS, Azure, Google Cloud, they are there almost all regions of the continents and countries basically. But before that, there used to be called, still these people exist actually, but not wide, they don't have too much of footprint, but anyway they do exist still. So what these people do, if you are region specific, my requirement, my application, my business runs only in a specific region, you go to one of the local vendor who gives the managed services. They will give you the entire servers, and they'll configure the server, they will keep the server under networking, they'll keep your server secured, they install whatever you wanted, they'll take the backup of your products, everything A to Z. They maintain everything for you, and you don't need to do anything. I need these many servers kind of thing, you have to order. They will include everything in that support cost as well as server cost, everything. These people are more advanced than the cloud, I would say, because these people maintain everything. In fact, you don't need to worry about anything. You just order the server, they maintain right from the provisioning to supporting model. You don't need to worry about. But these people don't exist around the world. When you globalize your business, these people don't have such existence or wide, the infrastructure deployed. So that's where these people are actually slowly wading away in the market. But like they do exist in some regions anyway. Whoever claiming their business is absolutely specific to region, they do claim this kind of services. Not all the cases anyway. So this used to be before the cloud evolved anyway. Nowadays, the if you take about the IT trend, it started to the onwards, right? 2008, the cloud actually giving a ready-made solution for anyone to go and build their infrastructure any of the continent. They no need to go to every region and build all of this expensive infrastructure, right? They cannot build in every region as they are growing it, because people are expanding the business to countries. They cannot go to every country and build a data center. It's not possible, because they'll have to invest a lot of money towards that, right? Everybody does the business just to gain the money from the market. They're gaining the market, investing somewhere entirely. That doesn't make sense at the end. They have to look at all the cost saving things, right? Right. Anyway, virtualization is also one of the important technology that have been released in 2000. Everything nowadays is virtualized. No one is running the physical. Maybe if they're running 1% in the market, 99% everything is absolutely virtualized. Before the virtualization, what used to be there, you spin up a or stand up a big server. The big server, why we need it? Because a server for one application need to be highly configured to just pick up the load during the peak hours. Okay, you'll have a peak hour in a day, 1 or 2 hours, but the rest of the day you are not using that infrastructure what is there on that server, big server, only for 2 hours. But what about the next 22 hours? You are invested on that, and you're not taking the use of that resources. That's where the virtualization will take care. You will build a big server. The shared infrastructure is given to each VM. One VM is taking, but other VM is idle. That time it is like you are overcommitting the resources actually in the infrastructure on the VMware side. If you know really about the VMware, you have the 10 CPUs, but 10 CPUs, 5 CPUs to 10 servers, they'll get 50 CPUs in fact. But physically there are only 10, but they are given as 50 CPUs. How they are sustaining? Because each server have the load and different times. Sometimes you'll get the your CPUs, there is no usage on the machine at all, but CPU shows that 100%. That's where the overcommit happens in the background. That is very depth subject actually. We will not focus that side. But uh, the VM side, if you look at, you are utilizing underlying your resources all the time, because you are given that resource to many servers. One server is not using, other server is definitely using for some maintenance activities or some background activity. So that way you're keeping your entire IT resource all the time busy, so that you're getting most of it what you invested out of it. That's what virtualization does basically. That's where everybody adopted so quickly in the market and took the benefit of it. So nowadays everybody are smart. Where they're getting the cost saving, people are quickly moving it, responding to it. Nowadays open source is growing very than the licensing products nowadays. So people are looking for the cost saving, and wherever possible they can use open source. They can take the risk actually. Something financial related, some sensitive data information, they may not go for the open sources. But there are a lot of applications which don't have the dependency. Absolutely, they are running on the open source and saving a lot of money, right? So people are smart nowadays. So that's what actually cloud is gaining it, because it is giving that kind of benefits to the people. Anyway, the next immediate slides will talk about the cloud benefits, where you understand why cloud is so important nowadays. So what is cloud
Ravindra,
computing? Yeah,
yeah, Ravindra.
someone have a question? Yeah, go ahead please.
Before, if nowadays these cloud service providers are using virtualization,
Okay.
so where the data centers were also using virtualization.
Right, of course. Everybody use. Rarely you might see a physical machine, because if you have Windows clustering, they cannot be virtualized disk. There should be generally RDM disk, physical disk only. Then only you get the proper IO. Else, if it is a VMD, also it will work, but it is shared. When it is shared, you don't get the absolute IO capacity. So you might see 1%, but 99% are absolutely virtualized, even if it is a private data centers or a cloud data centers whatsoever.
But virtualization is a new technology, no? Like, it came later, the later stages
Right.
of IT
It is
revolution.
a it started in 1999, but officially it is enrolled into the market in 2000. So it is widely there available in the market, everyone using it.
So do we have to say that, data centers came into picture after virtualization came into picture?
No, no,
Or
no.
can we say prior to that
Data
also data?
Data center is a house where you keep your physical servers also. It is everywhere, it is a physical. On top of it you have a technology. The virtualization is a logical technology. It's kind of, it's not a physical, basically
Yeah, I
software
understand.
which do
But
it.
virtualization is what gives them the edge of cost saving, right? Because they'll be able to
Right,
share physical
right,
server to many
mm,
clients.
y-
So that
right,
gives them that one cost.
right. So okay, what's the question there?
So, I mean, I just meant like, were data centers existing before virtualization came into picture? I just wanted to
Yeah,
understand.
data centers is just a house where you deploy a server. So virtualization is something, you divided a server. Before that, there used to be physical server, one dedicated server for one application kind of thing. They housed, there used to be a house for the servers, that is a data center. So that time you had a physical dedicated server for each application because there is no such technology to share it. So that data center concept is a since beginning of the IT resources anyway. But this is something is saving you in terms of cost because
Exactly.
you can get the resources shared across the machines, and each machine is actually using the same resource what is given by the physical host. So that actually you have a lot of things to verify in the real time to run your database very efficiently. The infrastructure side, they do overcome it a lot of time. So there are multiple settings to dedicate the resources from the the Hyper-V panel to the VM, or else there are many technologies, actually many techniques we will look at. That is very goes into different discussion side. But anyway, we'll stick to the database for now.
Yeah. Okay. Thank
So now, what is cloud computing? So cloud computing has lot of definitions on the web. You can find hundreds and thousands. But what is cloud? Cloud is something you keep your servers with someone third party, and they will maintain physical infrastructure. You will maintain your own software model, security, and there are many things which comes in a combination of both users. Cloud is absolutely responsible for securing the data, but you're also equally responsible securing the data. Why? Because you can create your own rules who can access your data, who cannot access your data. So you have the control on that. So you also have to equally playing the same role what Azure is playing almost to secure your data. I'm going to build use cases in our class. Like I'm going to who can access, who can should not access. We can open them, we can close them. Which network should talk, which network should not talk. I'm going to build geographic networks. I'm going to show that how the communication can happen. As a SQL DB, why we need to know all of this? Yes, we need to know because SQL integrated with the platform, and how the communication is open. When it is not open, how do you read it and tell them that it is not communicating because of this rule does not exist? So we're going to talk about a lot of things which will help for the SQL DB. I do cover infrastructure side also. So when you run into some issues, you need to understand the situation and respond to it. So that level of knowledge we'll definitely gain out of the class. I'll focus all dimensions anyway. Fine. Cloud computing, it is a use of remote servers on the internet to store, manage, and process the data rather than local system. You're not keeping anything yourself. Someone else is maintaining your data centers. It's not your data center, their data center. They're leasing you for you. You need a 10 servers. You're buying 10 servers, and you're maintaining the software on top of it. Hardware is with the provider. The software maintenance, the data protection maintenance, you're taking care of. Basically, uptime of the server you are maintaining, but the underlying infrastructure, whatever I discussed in the first slide, whatever we discussed, the DR plan, software licensing, and all that is absolutely included in the cost what they're giving. Basically, they are not charging everything extra. They'll give you the everything in when you're creating a machine, they will give you the amount how much you're going to pay by the month end or by hourly also, right? So cloud computing is an it is a delivery of on-demand computing resources over the internet on a pay-per-use basis. See, I need example 10 servers for my business. So especially e-commerce, if you take about the e-commerce business, especially, they do release the sales like big billion days or festival season. They do release a lot of sales kind of. When they release that kind of sales, they cannot even expect how much traffic that is going to hit from the market. So how do they scale? Even during the big billion days, you never see that Amazon site or Flipkart or anything is actually not responding. How do they actually do the scaling in the background? How do they sustain with the unexpected load? They're all running in the cloud. Mostly e-commerce people do prefer cloud only because cloud has given us such a flexibility. There is a auto scale set. The based on the load, servers will build automatically. If the server load comes down, the servers will destroy automatically. This kind of technology is there. This is self created technology. Absolutely, you just configure once, it will take care absolutely on there onwards. There are no issues with it. So we're going to see that in our class anyway, how the auto scaling can happen. Auto scaling only works towards a web server, not towards a database server. That anyway, I'll conclude it. Database server also, we have a pass model. Based on the load, it scale with the CPUs. Based on the load, it'll come down on its own. It will detect everything. Even it can give out all the resources back to the cloud when there is no uses at all. We're going to see a lot of wide variety of options anyway in the course. Cloud deployment models. This is very, very, very important. Public cloud, private cloud, hybrid cloud. Public cloud means you have Amazon, Azure, Google. There are many other small vendors, if you name it, but these are the top leaders in the cloud area at the moment. So public cloud is something is not restricted to anyone. Whoever have a credit card, they can subscribe, they can use the resources. It is not limited to anyone at all. Absolutely not at all. So anyone, available for everyone, anyone can go and sign up for the services and start using it as per their requirement. Anyway, everybody have an access. That doesn't mean that one resource owned by one other one can access it. Absolutely, they are isolated in the background with the private networks. How do you build your own private networks? How you segment the network into subnets, subnet into host, and make the communication? We're going to see 4 classes on that side. I have the dedicated classes towards networking side. No need to worry, we will spend good time there. Which means it's public, everybody can spin off, means no one cannot go to other services at all. Private cloud, everything is a cloud. Actually, why it is a cloud? You don't sit it behind the server or beside the server and then start working operating from there. Even private cloud, the organize, the data center owned by private organization, they keep the data center somewhere you access over the internet and start the operation, so that everything whatever you access over the internet is a cloud. Okay. Private cloud absolutely owned by single organizations. They are not meant for any other except that company. It's a proprietary basically. Hybrid is a combination of private and public. You are using, example, in case, take our case, so we are using 40% our infrastructure from on-prem, where we are running critical financial data in on-prem. So a lot of different applications are reporting around the globe. We are sending and invoices, absolutely running in the cloud. So we are using the combination of the resources on-prem and cloud. This kind of infrastructure model called as hybrid. You use your own infrastructure as well as take the benefit of the cloud where it is required. This kind of model is called hybrid benefit, hybrid cloud. So hybrid cloud is common everywhere. Everywhere, even banking sector also exploring the cloud benefits. Like they are not putting everything in the cloud, but the internal applications are something which is not critical in terms of data. They are operating from the cloud. Even banking sector, financial sectors also. So everyone trying to be hybrid nowadays. Maybe new startups are absolutely going to the cloud, public cloud, but existing people who are already have the data centers, they're trying to explore the hybrid model. Because see, if I buy a new server today, it will get outdated after 10 years for sure. The hardware will get outdated. So every time it get outdated, you have to buy the new hardware every time. Cloud is not like that. If the hardware where you're running, the hardware or software is the versions and hardware is outdated, you create a new server with the highest, sophisticated hardware and the highest version of software, migrate the data, destroy the old one. You're only paying to the one server. You're not caring about the old server at all. So down the line, cloud is definitely cost-effective solution compared to on-prem. Even if you don't follow the rules, your cloud is not cheap for now also, like whatever you're using. But in the downline, at least you will pay or you will save towards the infrastructure also. There are benefits. So that's why people are, going crazy behind the cloud nowadays. So what are the services we're going to learn? basically SaaS is something, it's a ready to use software. We are going to see some SaaS services as well, but mostly our focus goes towards IA services and PaaS services. SaaS service is something which is ready to use. You don't need to do anything. Just create the service and use it straight away. There is no admin required. There is no permissions required. Absolutely, it is a pre-configured, well deployed, tested, and it is ready to use software. If you go to the Play Stores, you go to the WhatsApp. WhatsApp, what you have to do, download, install, and you enter a number, give the message, and start using it. No one is approving or authorizing that app to use it, right? All Google, even GoToMeeting also, I did not do anything. I got the license from the GoToMeeting, and then they gave me a link, and I'm using it. So I gave you all the link and you joined it. So no one in the behind actually working for you to enabling or taking that service. So all that services comes under SaaS. Here Gmail, to create a Gmail or Hotmail or any webmail, you just have to register yourself by giving your details initially. Once you give your details, there onwards you don't need to do anything at all. No one is approving. It is already predefined, pre-approved. Everything is ready to use services. They are absolutely. So that kind of services comes under SaaS services. You don't control much. It is already deployed. There, every administration that you that has to be done is deployed in the background. You just spin off or subscribe and use it. All such kind of services comes under SaaS services. The best example is all your Google Play stores absolutely come under SaaS services. You don't do anything. You just download, install, and use it. That's it. So this is something ready to use software comes under SaaS model. PaaS is something, it is runs on top of the cloud without a VM. You don't create a VM, but you choose what software you wanted, what cost optimizations you wanted, what security models you wanted, what performance levels you wanted to keep it, what compliances you wanted to keep around. You can define what you wanted. There are scope for your administration here. There is no need to take the backup. There is no need to build a DR. There are many things again they are giving inbuilt, but here the PaaS is giving absolutely, like benefits, as well as you are getting the scope to maintain your infrastructure as you wish on few things, not on all things anyway. IaaS is something you create a VM. Whatever you do within the VM is absolutely comes under IaaS basically. Okay. So if you create a VM, within the VM, whatever you do, it is up to you. Microsoft doesn't care about it. Whatever the VM, whatever you do within the VM, you install a SQL server, you install a web services, you install a background service, any services that you wanted. Nothing actually, under, they don't ask any questions. Here in the past, what you wanted, you have to define, but here you don't have to. You just create a VM, create within the VM, you would do whatever you wanted to do. There is no control. The Microsoft actually control you at all. Within the VM, you do what they are giving you. Like, even if it is a on-prem VM, cloud VM, when you are working, you don't know the difference as long as someone is telling that it's a cloud VM. That's how it is basically. So they are giving like a logical box. On top of it, do whatever you wanted to do. It could be backend software, middleware, front end, whatever you wanted to do it, and you control it. If the VM is crashed, Microsoft is not responsible. Absolutely not responsible. You have to create a VM replication or always on. If it is a SQL, if it is a web app, something, you go with the auto scale set or else some different server set, so that something will protect. Basically, they're given all the options to protect. You have to claim it that everything what you configure is an extra cost. Okay. So PaaS is not like that. It is absolutely protected. You never see a corruption. 99 point total 9 nines, actually 9.979, your data is absolutely protected. How it is protected in the PaaS model, especially they keep multiple copies in the PaaS for everything what you deploy in the PaaS model. You have a example, one database assume case, they maintain 2 copies of your data absolutely in the background. Without your notice, you cannot connect or you cannot see this, but you can only see the actual live database. They maintain 2 copies in the background. They are actually sync continuously with your data. Why they are maintaining 2 copies in the background? If something is corrupted, the healthy copy will come and repair automatically. The user does not know that there is a corruption happened in the background and data got repaired at all. So they maintain multiple copies in the PaaS model by the design, and your data never corrupts. in the PaaS model. Your data DR plan you don't need to design in the PaaS, but in IaaS model you definitely have to. You are running the server and you created a VMDK disk array, a disk in the within the VM. A disk can corrupt. Microsoft will not help you in that direction. You have to protect the data what you have in it with the given technologies. So there are caveats between these two anyway. We're going to get clear-cut picture. When do we go to the PaaS? When do we go to the IaaS? There are certain limitations. In the PaaS model, if you are building a SQL server, by default it's 2019. There is no way that you can build a required version, right? Here you can install whatever the version you wanted. There are many differences anyway. There are many benefits here and many drawbacks. Here also many benefits and drawbacks. When to choose what? You don't get right now. It is not the class to talk about that. Anyway, we'll talk in the course when I wind up. I'll give a fair idea what to use when kind of. But let's just look at it. What on-prem look like, what infrastructure IaaS look like. So on-prem means you are fully responsible for every single thing. No one is actually come in between as a middleman and maintain it. You have to do everything. Here if it is a IaaS model, your networking means public networking. Private networking, you have to define, you have to, nothing need to maintain. You have to create, you have to design your networking model to have the private communication anyway. Public network is absolutely under not your control. It is under Microsoft control. Storage, you just, if I have 100 GB, I wanted to make 500 GB. I'll make 100 to 500 GB and save it. It will expand automatically to 500 GB. You don't know how many LUNs are logically joining and giving you that storage. It's none of your business. You just need a storage. You're getting it. And virtualization technique, absolutely, they are deployed a copy of it in the background. It uses that copy and deploy a machine automatically all the time with all the standards. You don't need to define anything. What you wanted to choose is OS operating system. There are two types of operating system in the cloud we have. One is a Windows operating system, next is Unix. Unix side also I'll spend one class. How do you create a Unix machines? How do you connect? How do you expand a disk? How do you basic administration? How do you do it? I'll dedicate one class for the Unix side. Anyway, it's not mandatory to learn, but you need to know how we can spin up the machines because SQL Server 2017 onwards, SQL Server 17 is a platform independent. It's not dependent anymore. 2016 SQL Server is tightly coupled with the Windows, but 2017 onwards, SQL Server runs on any platform basically. It's independent software. So you can run on the all Unix platforms along with the Windows. So that's where you need to have a little bit of idea towards Unix. So we'll see there. So middleware, runtime, data, what do you want it to do on the VM? Do it. Doesn't matter to the Microsoft. They're given a VM. On top of it, what do you want it to do? Do it. So you can stop the machine, you can stop the machine, you can do anything. PaaS services. PaaS services, by default, it is operating system to the 19 latest by default. You know to worry about. There is no thing like you can manage the underlying hardware or software. It is absolutely passed automatically and upgraded automatically. Everything does in the background. You know to worry about. So you cannot even maintain the middleware, the drivers, what it is doing in the background, what conversions it is doing. You don't worry about. They do it in the background. They have all the middleware conversion softwares in the background. Runtime also you cannot maintain. I have a SQL server I created in the past model. You cannot stop, you cannot start. There is no buttons given. It is absolutely runs 24 by 7 365 days. How do you do the maintenance activities when it is running? That's what we're going to see in our course anyway. There are server level, you don't need to worry. You have to worry about the database level in the past model. So we will spend good time there anyway. How we do the maintenance and all that. You maintain your data, what data is coming in, what data is going out, right? What applications you wanted to make the connections and all that, right? If it is SaaS, see, all are in red, right? So if you see, all are in orange. So if you look at this one, there is nothing you can do or I can do. It is fully deployed service. So this is how they are actually, segregated and defined. Any questions on this one from anyone? Please let me know, because this is important. The services are important. You need to have a fair idea what is SaaS, what is PaaS, what is IaaS. So you should get a fair, would have got some fair idea what these services are right now. This is SaaS means ready to use softwares. PaaS means a software which you run on top of the cloud without a VM, but you do control certain things. If it is a VM, any good example of PaaS? SQL Server. You create a SQL Server service on top of the PaaS, and it will come with a 2019 by default. And you don't need to take the database backup, you don't need to maintain the server uptime, you don't need to look at any infrastructure upgrades and patching and all that. It will be fully taken care by Microsoft. Their automated backups and data corruptions never see. So a lot of benefits you have here in the PaaS model. So you don't see that in the IaaS model. So you have all we're going to do is going to spend a lot of time on the PaaS only, especially the IaaS is actually close to on-prem. There are few differences. That is where I'm going to spend on the IaaS side. Anyway, we're going to spend 4 or 5 classes in the IaaS, creating a VM, installing the SQL Server, and automating of SQL Server installation within the VMs when it comes with all the standards, right? And how you can migrate the disk and how do you do the infra to lift and shift migrations. So we're going to see towards IaaS model also, right? That also will be covered, but the major focus goes towards PaaS because it's absolutely different than on-prem. Okay, we'll see there. Cloud benefit. This is where our major agenda will start. So cost is something. See, everybody doing the business absolutely for gaining the money from the market. No one is doing for the charity. People do the charity for gaining the fame, not for entirely losing the money. So okay, fine. Cost is something. If a startup company is actually trying to build a data center, they'll have to invest a lot of money, right? So if it is a cloud, upfront you don't need to pay. You build services, pay after 1 month, basically pay after quarterly also, or else you can pay you pay before and get the lot of benefits like a lot of deep discounts. Pay 1 year in advance, 2 year in advance, 3 years in advance. You'll get a 30% straight away, 50%, 60% straight away discount because you are paying in advance. If I'm not paying in advance, I had to go with the standard rates. Whatever the rate is there, that I had to pay. So you have there is a subscription, how you wanted to subscribe. Based on that, the cost will be varied basically, right? Anyway, what I wanted to focus here is cloud computing is eliminated the capital expense of the companies of buying hardware, software, setting up and running on-site data centers. So you don't need to do anything that we discussed in the first slide. Absolutely, you go to the cloud and build a server and give the services to the market. Once you get the money, you pay to the by the end of the month, you get the invoices, right? You get the money from the market, you pay back to the cloud. So once you accumulate the good money, maybe you might block the services for a longer time. Without the money, also you can run a business if you are selling good selling business if you have it. Maybe initially you have to bear up the cost because you don't get the money immediately from the market. But anyway, down the line you gain the market and you get the money and you start managing with the market money. You don't need to spend your money. If it is on-prem data centers, you have to do look after your infrastructure all the time. If it is about to fill up, you have to buy the hardware in advance and look for the capacity planning all the time. You don't need to do here. It is absolutely on the fly. Like you wanted a VM rescale to like 1 CPU to 10 CPUs, 100 CPUs, one click away job. It takes 1 minute downtime and VM will scale up automatically. There is never rejection happens in the background. They have the ocean of resources that in the background anyway. We're going to talk about how do they actually give the resources to the people without rejecting it. How it happens in the background. We have a discussion in the next 2 classes. I'm going to tell you that. So clients no need to maintain infrastructure, licenses, bandwidth, and air conditioning, water, everything. They don't need to maintain anything basically because it just you are subscribing the entire infrastructure. They are maintaining it. You are only installing your software and maintaining the data what you are keeping on top of the hardware. If it is a IaaS model, PaaS model again, it'll you don't need to worry about your data uptime, downtime, and all that, and upgrading it and patching it. Everything does in the background. How that will happen? Without seeing a downtime. They use Hyper-V clusters. So DRS means the VM will migrate online basically. You don't see that it is migrating anyway. There are such and certain discussions we will discuss there. You understand, okay? Global scale. See, nowadays everybody are trying to globalize their business. No one is trying to operate from one region. Everyone trying to build a their own data in different countries where they're trying to give services, right? So if example, you are building your own data center in one country but giving the data services across the globe in all the countries, what happens? You can give, it is possible. The problematic thing is performance. You are giving the services from one data center with gigantic and big data center. That's good enough, but the problem here is when you are sending the data to across two different countries through one uh, main data center, one country where it is sitting, it is possible, but you see the quite big performance issues. If that is the case, if example you are going to the ATM example, you are getting the money after half an hour. Do you go to that ATM or that service provider? Definitely not, because there are many other competitors. We are giving it within a minute. You can draw the amount. So performance matters everywhere. So you cannot go to every country and then build a data center also. That is also not a cheap solution, what we have seen. So cloud is giving a ready-made solution. Maybe you might keep one your data center. You keep creating resources in the cloud and synchronize the data in the background to one backend data center which you owned by you. It is possible. So global scale become very simple for anyone nowadays. They don't need to go to any country and build data centers there. They can, you have the, like Azure footprint, especially in every continent where they are using the IT resources, especially they keep building, year by year. In terms of resources, in terms of infrastructure, Azure is far ahead than the AWS. AWS is actually still leader in terms of revenue. Azure is the second place, but in terms of infrastructure, Azure is still leader. I mean, it is a leader. It is evolved in 2014. Actually, it is evolved in 2010, but the market responded to the Azure only after 2014, 14, 13 in that area. So what I mean to say here, guys, these global scale is absolutely made possible through the cloud without investing on the data centers, without investing too much money. It given ready-made solution to the companies. That's why people are adopting the cloud very rapidly. They don't want to invest too money unnecessarily when they are getting the services ready-madely and with a minimum resources maintenance. They don't need to maintain too many resources. They don't need to hire too many people also if it is a cloud. Okay. Especially for the cloud is a immediate threat to the infrastructure, like Hyper-V guys, backup guys, and storage guys. These people especially will get the too much of hit, and product people at least safe. Performance is also equally very, very important point to consider. What I said, when you globalize your business, you need to have your local copy in the cloud and serve the data to locally from that region, so that your applications function well, right? It is absolutely, you have to give that kind of performance model. Then only people sustain with you. You give a good service and more customers will enroll. That's how it is. And also, your software hardware time to time will get outdated, time to time. In fact, every 2 years, SQL Server itself, they're releasing the new versions. So when every time they are releasing the new version, they are giving the enhancements. When they're giving the enhancements, customers wanted it because the new model they wanted. People are agile. Every day they need a new feature, new requirement. People are coming with a different mindset and requirements. When it comes to fulfill that kind of requirements, you have to run latest softwares, then only it is possible. So that's where the softwares will give you the, good performance in terms of, they'll introduce a lot of new features. Using that features, you can enable certain features which can help you in terms of performance tuning, performance and all that. And also, if you wanted to upgrade a server from older to the newer to gain the performance, our legacy hardware is not giving, our legacy software is not giving certain features or the scale up capabilities, the technologies and all that, you have to upgrade and then gain the benefit of that newer versions and hardware and software. In that case also, in case of on-prem, if you wanted to destroy a machine, you don't want that hardware anymore because it's absolutely outdated, you have to give that to the scrap vendor. Again will charge you to for scrapping. They'll definitely scrap it, kind of. You have to give the money to scrap that infrastructure. Okay, you're not getting anything, you're paying in return again. If it is a cloud, the old hardware, I'll just create a new machine parallelly, migrate all of the data, destroy the old one. I'm not paying anything at all to the scrapping, or I did not invest on the hardware metals also, just I am just migrating to the new host as I'm required. So this way you are keep bumping up your resources and in terms of hardware and software and getting the required performance. Okay, that is directly implied. Okay, so these are all major benefits you need to understand. Speed, if it is on-prem, if I wanted a new server, I know that my infrastructure about to fill up and I have to add a 30 more percent free buffer all the time. So I have to go to the finance team, get the finance approval, go to the procurement, give the give to the procurement team that get this infrastructure. Procurement will go to the vendor and they'll work with the vendor. Vendor build according to your requirement and specifications. They deliver the infrastructure. Then then that has to be attached to the network cables and install the operating system. Give it to the product guy. Then he will install and hand over. This is a lengthy process. If it is a cloud, there is nothing. You don't need to do capacity planning, anything. In a 1 minute, you just run one single automation. It runs 10 machines, 20 machines, 100 machines. So it takes minutes, not hours even. You create any big server, it takes hardly 2 to 4 minutes to build a server. Within 4 minutes, you have the server with any configuration that you wanted. There is no capacity planning you have to do. It is a agile. You just click a machine, click few buttons, the machine will come and then install the required product and give it to the application team to do whatever they want to do, right? So the speed of the delivery of resources become more fast because you no need to do anything in the background. It is there readily available with the in the background. Agility in provisioning of computing resources through self-service on-demand features enable flexible depressurized capacity planning. You don't need to do capacity planning at all because it is rare in the background. You give the numbers, it will scale up to the numbers whatever you give it. That's it. You don't need to pre-plan for any resource. When it is required, you give the required configuration and scale up the resources whatever the level you wanted. That is called the speed in delivery of the resources become very quick without any capacity planning. Enhanced productivity. This is another major factor for any company to consider. See, when few things are automated, you don't need too many infrastructure guys like storage guys, Hyper-V guys, backup guys, right? Windows guys. You don't need too many people because that is maintained by the cloud provider. So that way you are saving a lot of employees work. If you are saving the employees work, let them do some other job, like let them learn different technologies and make them enable them to work in a different ways basically for a company if they are not firing for any reason. So they'll give some training, they'll enable the employees to do some other work in terms of uh, to uh, to enhance their business, basically, right? So see, when the cloud was not there, if one guy is good in one technology, he used to get paid absolutely, good amount. Now, if you are a SME in one technology, you know in and out, no one is caring about. If you know one technology, you're outdated, as simple as it is. That's because of the cloud only. Cloud has given these things to the market. One guy need to work on multiple things because cloud has given such ready-made things. So one should work on one or two technologies, at least two, so that you get the value in the market because of the cloud has given this kind of things we see here. Remove of needing of stacking and racking and hardware setup patching. You don't do even as a database admin also. You don't do the software patching or hardware patching in the past model. So what you have to do, there is a inbuilt automatic performance tuning also. There are certain features are there I'm going to talk about. That is not so great, but anyway somewhat certain extent it will help you. So when things are ready made, you don't have much of work. When you don't have much of work, try to work on something else. That's what the companies push to the people to learn something, so that they can work on multiple parallel technologies to they can sustain. That's where this requirement started, because of the cloud only, I would say. Before that there was no such thing. If you are a good in one technology, absolutely you will be valued employee and you will be paid according to the market scale anyway. So nowadays no one is caring about even you are very good at one technology. They are trying to ask you to learn some other, then you get a value of. So that's how this is something, guys. Enhancing the productivity in the sense that employees are getting the time to learn new technologies or to gain the other knowledge, and companies getting the gain from one employee to get the service on multiple technologies basically. That is one of the considerable fact. Reliability, this is very very important point out of all, I would say. Reliability talks about how secure my data in the cloud, how I can recover the data in the event of loss. There are 2 points it talks about: reliability of data and reliability of security. How secure my data? 2 points basically. Your data absolutely safe in the cloud as long as you are losing your rule set to the market. See, if you're creating a VM disk are by default encrypted. If someone is stealing the data from Microsoft infrastructure in the back end, they will not do anything with that. It is encrypted by default. When you are creating a VM disk, by default it is encrypted in the infrastructure and the hardware. So even if I'm creating the past database, by default it is encrypted. You don't need to apply any encryption on the past database. By default it is encrypted. That is why we will go with the backpack. We're going to talk about why it is a backpack, why not BAK. I'm going to share all my knowledge, guys. Whatever I gained through all close to 7 years, I'm going to share all my. This is not what is what. Our course is not what is what. We'll spend towards troubleshooting, especially understanding how things are in the cloud, how we can easily troubleshoot, and when how you can work as an independent guy in the cloud. That is very, very important. So let's focus on reliability, guys. As I said, if you have your PaaS model, they are maintaining multiple copies of your data. Come on, where it is gone? Somewhere right on the right, fine, whatever it is. So if it is a PaaS model, your data is secure by making 3 copies of your data. One copy, any service, it doesn't for that matter, it is a skill or any other service you will take it about, they maintain 2 other in the background to protect your service up and running all the time. It never get an interruption because there are other 2 copies. If any hardware crash or a corruption happen, this will come and replace the data with the healthy data. Whatever is corrupted, it does a checksum in the background with the other copy. Whatever is actually corrupted, it will come and repair. The user does not know that there is a corruption happened, it got repaired. Okay. And the backups also, you have the backups here, and one backup will get geo replicated to other region. Though one region entirely down, this copy will protect. And example, the backup is continuous. You no need to order it. Basically it does like this: one copy will be taken, one will sync in the background, from the synced backup again this will sync. So this backup will be always 1 hour behind the live backups. We're going to see this in live. We're going to see that. So even your database is deleted by mistake, you have 100% protection except the downtime. You deleted a VM by default, by mistake, you still have a recovery of the VM. You don't lose anything except the downtime. So we have all the mechanisms in the cloud to protect the data. In even you do a mistake, still you can recoverable. Even a VM deleted, you can recover. Even database deleted, you can recover. I'm going to show that in practical. We can. I build a product. I'll do that. Delete it and recover it. We're going to see that. The point here, what I wanted to make is data is secure enough in the cloud because they are maintaining this kind of model. Though you do a mistake, still you can recover the data. And let's come to the security model. Your data is encrypted by default. In terms of VMDK disks are encrypted. Even you create a PaaS database, by default it is encrypted. So with a Microsoft, your data is encrypted. And security in terms of network, Microsoft will not allow you any network to talk to your network by default. You have to enable what networks to talk to that network. You are giving that access. So if you are not creating a proper rules to which network will need to talk, then you are doing a mistake, not the Microsoft. Microsoft is isolated your infrastructure. No one can talk to that. And who can talk? You are making that role. You have that responsibility. You have that control. Who should talk? So when you are creating a your rule set, you are giving a bad rule which will allowing the other network other than yours. Then it's your mistake, not the Microsoft. Microsoft has secured in all directions. Not only Microsoft, all cloud provider does the same job. So it is protected in all directions. If you create a PaaS SQL server, no one can connect. Even local private network also cannot connect. You have to enable or integrate that local network, or else you enable the public network or enable the Azure infrastructure. Every option is given, but you have to take that what you wanted basically. Where the risk is involved, you have to analyze and open it accordingly. But by default, no communication can be made to the any service that is spinned off in the background by default. You created a rule set, you attaching that rule set to the service, and based on the rule set that you define, the communication can happen. So in terms of security, in terms of data recovery, cloud has given all options. If it is a VM model, my data can corrupt on the disk. There is no protection for it. It is a PaaS. Okay, data corruption is never happens because it does auto recovery. But what about the VM? If it is a VM, disk can corrupt. They have given a non-corrupted backups how you can take it in the cloud. It never corrupts. There is a service which will act like a third party, and recovery also one click away recovery even if it is a VM. So we are going to talk about all that options anyway. Data recoveries and security is absolutely guaranteed in the cloud. That's something I just wanted to stress. Why? Because this is something is a has a high weightage than other benefits. If you cannot recover the data, if you cannot secure the data, all these benefits are secondary, right? The reliability makes very bigger point, especially out of all. So these are all very important, guys. Cost and global scale, performance and speed, enhance productivity and reliability. These points are making nowadays people look for towards the cloud, especially. Cloud is giving almost everything what you wanted. Even you can run the financial sector also in the cloud. People are not little bit not comfortable, but cloud, when WannaCry was attacked, every infrastructure is attacked except the cloud. Cloud was never attacked by any viruses so far, because they keep the infrastructure such securely that no one can come and hack it, because they keep a lot of layers. Only they can hack through your layer, your network rules layer, not the Microsoft or not any provider layer. So that's how the cloud is basically. Okay, so when we have Azure, AWS, Google, or any many other small cloud providers, why we need to learn Azure? That's the point, right? The point here is for Microsoft products. If you are using the Microsoft products, you are onboarding into the Microsoft, you will straight away get the deeper discounts, hybrid benefits first. Hybrid benefits, whenever I'm going to show that tomorrow. Anyway, we are talking orally today. Next class, we're going to get into the slowly to the technical side anyway. Okay. So today is only information. First, you need to know what you are trying to learn, right? First, understand it. Then we'll enter into the technical side. Technical side, anyway, you can understand. But why you are learning it, that's something is very important. So Azure is actually giving deeper discounts for the Microsoft products first. If you are onboarding Microsoft product into Azure cloud, you definitely get the benefit. So let me show you this one thing before I talk about that. Azure is 5 times less than AWS. You can see this message on the official website. What they are claiming here is uh, AWS is 5 times more expensive than Azure for Windows and SQL Server. If you are running the SQL Server product, 5 times, if you are paying $100 for the in the Azure, you only pay the $20. See the variation of the charges basically. They're attracting, they're giving the like too much of deeper discounts to attract all Microsoft products, especially first. If all Microsoft products are coming towards Azure, that's enough to beat any competitor in the market basically. So still people are on AWS. We initially, when I started my career in my company, they had a lot of AWS servers. We migrated from entirely from AWS to Azure now, almost everything. The reason behind is the SQL Server, it's a Windows Microsoft product. That's where the SQL DBAs are getting the immediate requirement on the Azure side, especially. Why? Because SQL Server is a Microsoft product, Azure is also a Microsoft product. That's where the benefit they are giving it. So 5 times is not small thing, right? You are saving too much of money by coming to the Azure, for especially for the Microsoft products I'm talking about, right? So that way, whoever SQL DB, the immediate cloud add-on is Azure nowadays, because Azure has such a bigger footprint nowadays. It's becoming towards the SQL side. AWS is also equally competitive in terms of revenue. In terms of revenue, because it started in 2008, old, it's an old one. If you look at the Azure, it started 2010, but actual gaining the market 2014 onwards. So if you look at this one, it is 6 years behind the scene, the Azure, but still they are far ahead than the AWS in terms of infrastructure now. Infrastructure wise, Azure is a leader as of now. And revenue wise, there is a 4 to 5% difference. This is gaining 42%, this is gaining up to 32 37% of the market basically. Google is far behind anyway, at the moment, compared to these two cloud providers. In terms of revenue, I'm talking about infrastructure. Google also trying to catch up, but not at the market at the moment. It takes time. So why we need to learn Azure again? Azure products, not only, all Microsoft products. You take about Microsoft products, even I know AWS, I know Azure. AWS is very complex. Migration you wanted to do, or you wanted to move a database backup from the S3 bucket to VM, it has a lot of complexity. You need a third-party software in between. Or else Storage Explorer, there is some computing device you have to build, and through that you have to access. Azure is no such thing. You don't have anything. straight away, straightforward. Everything is simple and straightforward. They make things very user friendly. That's the biggest selling point for the Microsoft for any product. Microsoft look for the user friendly products. Whatever they build it, they make UI based products, and they make things easier for the people. If it is easier, more people can learn, more people can support. So the more the product is gaining the market, the more people required. If more people are cannot learn the product, you are having the benefits, no one is ready to support, then it will be a big problem. That's what another thing Microsoft always focus: user friendly products. Always, they don't make things complex, they make things easier. It does in the background for you. A lot of things it will do in the background. If you go to the SQL and Oracle, what is the main difference? That runs on the Linux platform where you have to run all the commands. If it is SQL server, mostly you go with the wizards, so which is easily to learn, right? That's how, I mean, the product, they will make easier for the people to learn and adopt. Basically, when you get more technicians available to support, the product is also growing. So both go in hand, right? That's how it is. Easy to learn, rapid growth in the cloud computing. They are building too many regions basically than AWS compared to, and the most computing power is in the Azure, not than AWS comparatively, and more regions and data centers than any other competitor at the moment. So at the moment, the Azure is absolutely top leader in terms of infrastructure as of now. Cost effective compared to other competitors, absolutely cost effective compared to AWS. That is, we have seen. Now, what certifications you can do after this course? Basically, you can go with the AG104. This will be covered a lot, but not 100%. But DP300 is something you can go for it. This is a database designing and implementation of cloud data platform solutions. This is something you can take it up after this course, right? So this is all I wanted to give as a agenda of this class and demo as of now, guys. Please come up with your question if you have anything in your mind. It's not one-way traffic. I do entertain each and every individual question in the class. You just ask your question. I'll try to keep the discussion that side, because I have a vast experience on these technologies, because I am working the last 14 years, and Azure also last 7 years, almost close to. So most of the services I know. Just you have to speak up and get the output. I mean, I do give my part as my responsibility, but if you have, please speak up. Yes or no? You have a question?
Yeah, Ravi, basically I am a DB to DBA, okay? So just a beginner to Azure, okay? So as a beginner, right? So whether this course will be able to cope up with the Azure concepts, or you want us to like go over the Azure fundamentals, or so that it would be easy for me to catch up the course. Like, what do you suggest for beginners?
See, if you are DB2 and you don't have any exposure towards SQL, maybe you have to gain the knowledge in the beginning. At least you have to spend on the basics, especially how SQL technologies will work. We'll spend towards infrastructure up to 10 to 11 classes. Then we'll focus mostly towards Azure SQL, how we can implement, how we can. It is similar with every product anyway. The pass model, security model, compliances, monitoring, and checking the metrics, and everything is same except the product.
Okay,
almost.
Okay.
And just to be attentive to the class. Don't I'll share the video every day, but don't depend on the videos, guys. I would recommend all of you to attend the classes to gain most of it, right? That's very important. Yeah, any other questions from anyone? I mean, if you have in your head, just put it out so that I'll answer your question. I mean, I'm here to answer.
One more thing, Ravi. So whenever you're referencing any Azure services, right? It would be great if you could relate that particular service, equivalent service in AWS, if you have any idea, right? Since I know a bit of AWS, so it would be easy for me to relate that particular, say for example, the EC2, the corresponding one in Azure, right? So something like that.
Okay, it is simple. See, we work in 3 segments: VM, storage, and SQL. Especially this segment, I can easily refer. No need to worry. Equivalent services.
Sure, thanks.
Yeah. So any other question from anyone, guys? If not, I'll stop the video and then I'll talk. Stay back.
Ravinder, so